Vi har Normann Dunne med os live fra Irland. Normann han er nyvalgt formand for den irske base-afdeling, og base er det her med udgangspunkt i Frederik Thomas fra Frankrig, en fransk-engelsk-irsk forening for landmænd, der er arbejder med conservation agriculture og regenerative agriculture. Normann han driver 150 hektar blandet landbrug i County Kildare, cirka 30 km vest for Dublin. Normann han dyrker primært hvede, byg, bønner, ærter, raps, og så har han æglæggende høns. Så det bliver spændende at høre, hvordan han integrerer det rundt i sin feltskifte. Han har praktiseret CA siden 2018. Han står med en John Deere 750A. Jeg er sikker på, at Normann fortæller os meget mere om det, men det er også med udgangspunkt i, at vi lige har haft en artikel i FRDK-bladet med Normann. Og som lille sidste gimmick her, det er, at Normann han i 2018 blev hans jord kåret som Irlands dårligste landbrugsjord. Normalt plejer vi at tilskynde folk til at få kåret den bedste landbrugsjord, men i det her tilfælde, så har man i Irland åbenbart valgt at kåre den dårligste landbrugsjord. Så nu må vi så se, hvordan Normann han holder modet oppe. Og så er der lidt forskellige andre ting, men det kommer vi tilbage til i forbindelse med Normanns oplæg. So Normann, thank you very much for joining us today, and we are all
thank you for having me.
We are all very eager to hear what you have presented for us. I think we will mainly let you do the presentation, and then few follow-up questions during your presentation, but then the main questions afterward, I think. But maybe you have already built in some slots for questions in your presentation.
Yeah, no problem at all. I hope there'll be plenty of time for questions at the end. So I'll get going, I suppose.
And Norm, I can hear from your lovely Irish accent. Then please speak a little bit slow, so everybody
okay.
Can get you on. So thank you very much, and please take us away.
No problem. Thank you. Okay, I'll just give you guys a bit of background information or context of what goes on in the farm. So I'm farming together with my father, Michael. That is 76 years of age as of last week. We are both full-time on the farm, and we take in 2 part-time employees over the summer months. Together we farm 400 acres of arable land, and we rent 200 acres of grassland for hay production in the equine market. I had been working part-time on the farm up until 2011 and became full-time in 2012. We had no livestock up to this point, and we were in a continuous serial, no sort of rotation, plough, till, sow, conventional system. Started to think differently back in 2015, continuously looking at tired, worn out soils with no earthworms, turning over sods of clay with the plough and turning it over, and it was a lackey sort of clay, very hard to get a seed bed with it. So that drew our attention to looking at things differently. I attended a biological soils course in Ireland run by a man called David Wallace, and he opened the door to soil biology to me and conservation agriculture. In the same year, I came across Base Ireland, which is a conservation agriculture group and the main body in Ireland for conservation agriculture. As it so happens, I'm chairman. I just became chairman of that organization this year, so I have a eventful 2 years to go ahead. We grew our first cover crops in 2016, and hired a direct drill to sow beans in the following spring of 2017, and we hired the same direct drill again, a weaving drill, in the autumn to sow winter wheat. Both were very successful. Even 2018 was a drought year, so uh, we felt we had a bit of resilience with not turning soil over and held a bit more moisture in our soils. Our livestock now consists of laying hens, a small amount of sheep, and a small amount of pigs. The pigs and the sheep are predominantly used to produce food for our own households. So my household and my father's household, we feed the two families with meat from produced from those. We now grow winter wheat, winter barley, winter oilseed rape, spring beans, spring oats, spring barley, spring wheat, overwinter cover crops and summer cover crops in between cereal crops sometimes. We grow companion crops with our OSR, which consists of buckwheat, sunflower, phacelia, and berseem clover. A lot of these have winter killed over the winter. We've had probably a harsher winter than we normally have here. So a lot of them have already been winter killed. And the plan is to stitch peas into this rape over the next week or two to become a combi crop and harvest together and separate later. I think I had some of your colleagues out, not last autumn, the autumn previous, where I had bought an Austrian winter pea to put in with the oilseed rape. And it worked very well until we got a sharp frost in March or a late frost in March when the peas had expelled from a mild winter. They were nearly at flowering stage, and the first frost they got wiped them out. So we're changing now to a spring pea, stitching it into the rape afterwards to see can we get the two crops to come together, fix a bit of nitrogen, and put a bit more root architecture into the soil. Other combi crops we've grown and growing are spring barley with peas, spring oats with peas, and spring beans with oats. We find that these combinations complement each other. It's another set of root architecture and root exits coming into the ground. And they complement each other very well. Look, this is a bit dramatic, this photo, but it kind of it puts where we might have been starting from, continuously beating hell out of soil to get seed bed. Now we're more towards the regenerative side there. We're trying to keep living roots in the ground the whole time, above ground diversity and a below ground diversity. And look, it's better for us and it's better for nature. Changing systems from what you know to what you don't know can be a risky business, especially if you're going in blind. We run a risk mitigation policy here at the start, and we continue that as we go as well. We run 4 tractors, all coming up on 20 years old, which are fully owned. We've no repayments. Probably should have. We've two loaders as well, teleporters. They're owned. A combine is owned. All our arable land is owned. We keep most of our implements kind of fresh, so our drills, compost spreader, sprayers and stuff are all very well kept up to date. This is where we'll have loan repayments and stuff. So other ways to reduce risk, we save 95% of our seed, we clean it ourselves, and we apply biological dressings to the seed. So if in the event that we have unforeseen weather or some sort of failure in a crop, the costs are minimal for us, and it's literally only a run of the disc or a run of the drill to sow the seeds, and the seed itself is saved at home. This also allows us to sow at a much higher seeding rates, and can combat pests such as slugs and crows, and slow or poor germination. This also helps with plant counts and tillering, and as I said, keeps costs minimal should there be a failure. Never be afraid to try something new. remember the amateurs built the Ark and professionals built the Titanic. So we now follow the three principles of conservation agriculture. So soil armor, you can see by the trash here in the growing crop. I think it's a growing crop of winter barley into a summer cover crop. So you can see the residue of the cover crop is lying down on the ground here, protecting the soil from adverse weather conditions, and it's also reducing weed burden as it doesn't give an opportunity for weeds to get light or germinate. Doesn't always stop it, mind you, but it does help. The minimum disturbance then is we run a John Deere drill, disc drill, allows us to go into living cover crops, can go into cultivated soil if you want as well. Just gives us more options. Then the crop rotations, we grow 50% spring crops and 50% winter crops. And we move them around continuously. This allows us to put cover crops in and multi-species cover crops in, and move them around, giving us a much broader choice in rotations. As again, that's how we sow into living covers. So I think there was beans going into this cover crop last year. Beans are probably the best introductory into the system, because the bean seed is so resilient and it'll put up with a little bit more hardship if needed. Again, the same. How are we implementing this? So we're growing multi-species cover crops. We're keeping our rotations as diverse as possible. They're not always perfect, they're not always ideal sometimes, and it's on a year by year basis, so no 2 years are the same. We are growing companion cropping and combi cropping crops as well. We have done all-brack soil tests, and we are looking heavily into balancing calcium and magnesium ratios. So we're on a heavy calcium clay soil, and we're dominated by calcium. So in order to try and bring back the calcium and increase the magnesium, we are spreading a bag of Keystrite every year. The sulfur should strip the calcium down a bit and make room on the colloid for some magnesium. We're chopping an awful lot of straw and trying to make as good quality compost as we can. We're adding carbon sources with our nitrogen where and when we can. We're using sap analysis to try and balance nutrition. We're brewing up foliar sprays to suit sap analysis and reduce nitrogen. We're home saving seed and using biological seed dressings. Our seed inoculation then is if you look to the left, you'll see this is how we used to dress our seed. That's my dad there in the background raking the seed on the floor. So we would have spread 1.5 tons, maybe 2 tons of seed out on the floor, and sprayed the seed out on the ground and raked it in and gathered it up after. You can see there by the root or the clay adhesion to the roots, there's good exudates coming out from the newborn seed. Some bean seeds there as well, and some wheat there, I think. There it is in that's myself there spraying on the seed onto the ground. It's very labor intensive the way we did. We have changed it up now to using an auger off the seed cleaner, and we do it all in one sweep. I think I have it on the slide anyway. So again, if you see this happening in plants, soil adhesion to the roots, it's good biological activity happening between the soil and the seed. It's getting your seedlings off to a good start and a non-stressful start, potentially getting you to a healthy crop with less inputs. Again, the same soil adhesion there again. Lactic acid bacteria. I know some of you guys were over in the autumn and I was explaining this to you. we make a lab at home here, and we use it as a seed dressing. So that here is a grain wash water. We sprout all our own seeds for our hens to feed them. So when we soak the actual grains, the water has to be drained off, and this is the drained water that comes from the soaked seeds. And that's left for 4 days to inoculate bacteria from the air. We add that then to raw milk from a neighbor, a dairy neighbor. That separates the curd and the fats from the milk, and you end up with this lab serum, is what it's called. Um, you can see it there. It's kind of a, a, a yellowy sort of a color, and that's it there as well before it's properly filtered. We use this to spray onto our crops. It's a phosphorus solubilizing bacteria, so it's ideal probably in that seedling zone area. It's also known as a soldier bacteria, so it likes to hunt out pathogens and eat them as well. Um, so effectively, it's nearly like a probiotic to a seedling. Um, we're also experimenting with some Korean natural farming methods. IMO, the indigenous microorganisms. I haven't fully got a grasp of it yet, and I haven't been confident enough to get a good collection, but basically it consists of putting half-cooked rice into a breedable box and putting it into a woodland area where it draws in natural fungi and nematodes and protozoa all and into this small little box, and you culture them uh, and mix them with rice and sugar. So um, going forward, I'd like to inoculate our compost before it goes out with a finished product like this, and spray it out onto crops. It'll be highly beneficial. This is a typical recipe that we'd use on seed dressing. So, 2 liters of vermi extract. I'll show you later in a slide there where we have a wormery made, a homemade wormery where we extract the vermi extract from. 6 liters of Humifirst, which is a mixture of humic and fulvic acid. The lab then, as you saw on the previous slide, that gets 4 liters into it. Liquid seaweed then as well, there's 2 liters. 1 liter of molasses. We have played around with this. I might up it a small bit. The sugar would be a good energy source in that for biology. Oriental herb nutrient then as well, which is another KNF recipe that you can make. It's like an antiviral. It's too complicated to go into, but we add a bit of that to the mix, and sometimes we buy in mycorrhizal inoculant. It comes in a dust form like sand, and we just mix it in with a whole lot together and apply it onto the seeds. Our compost then, look, we've started making a lot of compost at home. We make windrow compost, and we make vermicompost. So the windrow compost is done with I'll show you here now. It's done with a compost turner. So the whole idea is that we get enough ingredients to mix that we can try and balance the carbon to nitrogen ratio and get an easy and quick breakdown of the materials. Not always possible for us because we take in straw, manure, horse manure, and there's a lot of horse manure around us, which is to be very high carbon content of wood chip and wood shavings and sawdust. And then the manure would be straw-based cattle manure. I suppose the turner helps speed up the process as well. And it gives every bit of it should get some time in the center to 65 degrees Celsius, so that it'll kill any pathogens or weed seeds, um, leaving a stabilized product to spread at the end of the day. Um, we purchased this compost spreader in maybe 3 years ago. So it allows us to keep controlled traffic. So there could be 18 ton in this spreader here at this minute. I don't like traffic driving all over the field, especially since we don't plow anymore. It does travel better, but if you're continuously traveling on ground, that you will compact it. It's an Irish machine. It's a very simple machine. So the chains here pull the material back. This rotor turns around and chips away at the compost coming towards it, and it drops it onto the discs. It's capable of spreading up to 30 meters if the consistency of the material is right. We are on 24-meter tram lines, so it's ideal for us that we stick to the controlled traffic. The machine stays on the tram lines, and there's no further compaction elsewhere in the field. This is the IBC wormery, the wormery that we were referring to there to extract the vermi extract. It's literally just an old IBC that was damaged in the yard. We cut the top off it, turned it upside down, drilled a whole pile of holes in it, and put the lid back down into the IBC itself, as it fits perfectly into all the nooks and crevices there. That's put up on blocks and cardboard put over it then. And there's a valve on the outside of the IBC that catches the water coming off. Going forward for the seed dressing for vermi, we're actually looking at making a worm cast slurry. So we're just extracting the worm castings from the bin, and we're mixing it with water and making a slurry. It's something that we hope to do this spring on seed dressing. Of course, all of this then is feeding biology, and we're balancing soil nutrients all at the same time. It's a cycling program. I'm glad that we didn't introduce the compost too early in the system or the changeover, because we actually got to see what multi-species cover crops were doing and how fast they were doing it before compost could have come in and taking the credit for maybe overseeing the cover crops. This is a compost brewer that we have in the yard. We melt urea and mix up and tailor our foliar sprays with this here. So it's conical, so everything we blow, it's agitated by air. So there's an air line at the top here at the back that comes down and blows air up through here, and it comes up to the center and regurgitates back down again and keeps everything moving. So we melt urea, we melt magnesium, any amount of things that we want in there. And I have all of our ingredients kind of close by. So there's the Humifirst is here, the seaweed is here, the molasses is here, and there's drums of other stuff that I can get my hands on fairly quick, and steps up here that it's easily accessible to get in and out. This is just a typical foliar nutrition spray that we would use. From tailoring the sap analysis, we have come across that magnesium is majorly deficient in the leaf and the sap. So nearly every spray we get some sort of magnesium sulfate out. We have tailored different ingredients to suit sap analysis results. Potassium sulfate at flowering or grain fill to help grain fill, magnesium sulfate, potassium silicate, sodium molybdenate, anything to help with photosynthesis and improve yield and reduce inputs. Um, we I have moved towards buying a pre-mixed multivitamin, which is quite it saves on time trying to mix straights, and sometimes mixing straights can go wrong, and you like say potassium silicate can separate things in the mix and maybe clog your sprayer. Um, so I'd be very wary of just that one. Everything else seems to work fairly well, but it's always important to do a bucket test before you go mixing a big batch. So the pre-mixed multivitamin is very handy. Like we can put boron, zinc, cobalt, molybdenum, and iron is the typical multivitamin mix in that. Um, and that takes a lot of labor out of what we're trying to do. Cover crops. Look, that's very hard to see on my pictures, but uh, that's like a typical mix that we would use. Um, and we would add more. So there's Phacelia, buckwheat, mustard, oil radish, common vetch, tillage radish. We would add linseed, sunflower, depending on the time of year. Um, Try and keep the mix as diverse as possible, so anywhere between 7 and 10 species. Um, this is a field that's in longest in the system, so you can see by the color of the soil, uh, there's plenty of aeration. There's no need to be tilling. There's no need to be ripping up or doing anything to that soil. It's perfectly friable underneath. And the roots and the worms are keeping it alive. Um, if you look at, say, a 7-way mix versus a monoculture single mix, it'll take a monoculture farmer 7 years to get the same root architecture and root exudates into that soil, and we've done it in 1 year or more, probably because we'll have a cereal crop or something following it. So that's even with 7 species and one species of cereal, that's 8 species, which would take a normal farmer 8 years to accomplish, and we've accomplished it in 1 year. This is just a picture from the autumn just gone. So this was a spring barley crop with chopped straw. My father drilled this in early September. And this here is a drill miss. So he won't like me to show you this, but it's a full width of the drill missed, and we didn't miss an opportunity to get in and dig and see what was going on in here and what was going on in here. So believe it or not, that's the same soil in the same field in the same picture that you've just looked at. Uh, this was the one with a 7-way mix of uh, cover crop and 6 weeks of growth. And this is the drill miss. You can see plenty of soil aggregation, plenty of roots, darker color, um, versus this lighter color. It looks compacted. Even though there is soil armor there, there's chopped straw here. It's ticking one of the boxes of conservation agriculture, but there's no porosity, or there's no air getting down here, or no carbon being pumped around. This you can see it. It's very visual. Success is not always what you see, as you can see there by those 2 pictures that I showed previously. You can have an awful lot of above biomass, but not a whole lot going on underneath. I often look at a poor cover crop, or someone might say that your cover crops are very poor looking. It's not till you get a spade into that ground and see what's going on that you can actually see that the poor cover crop is doing much more than you think it is. Again, look, that's small plant. I think it's a rape plant, or yeah, it is a rape plant, stubble rape plant. There it is. It's probably 9 inches of a root, and I didn't get it all out. So Small plant, big root. We want to be pushing those roots down all the time. We have experimented with different cover crop destruction or taking cover crops out. One is where we will flail 2 or 3 weeks beforehand. It works very well. It creates that soil armor as it chops it really fine and above the ground, but we find that we can't hang on to the trash that long. It gets eaten by biology or taken down by worms. So we do use glyphosate. We try and keep glyphosate to a minimum of just on cover crop destruction. We do reduce our rates by lowering the pH by adding citric acid, and we chelate it with fulvic acid as well, which helps it draw into the plant and doesn't harm biology as much. Yeah, we're messing around at the minute with establishing cover crops and labor and machines. So this is something that we are going ahead with this year, or we have started anyway. Is a seeder on the header of the combine. So we're intending on chopping 95% of our straw this year. So we saw this first hand in England many years ago, where a farmer, what's his name? Richard Tomlinson from England, implemented this. He put the seeder on the header, and he chopped his straw. So when he was cutting, he would have broadcast the seed out here on these spread plates on the header, uh, chopped the straw over the seed, uh, locking in the moisture that there's a moisture layer there when you take a crop off. You might get 1 or 2 days before it dries out. So by chopping the straw over the seed, you create a microclimate nearly for the seed, and we have tested that here by broadcasting seed behind the header of the combine and chopping straw over it, and it has been by far our best establishment for our cover crops or late cover crops growing. We've been very happy with it, so we've decided to go ahead with this system. Combi crops then. So we're trying to, again, it's about keeping more diversity in your crop and in your soil. Um, the pea barley, pea oats, that they're fixing atmospheric nitrogen naturally. It's more diversity. Um, it's they complement each other very well. The Native Americans had that planting technique a long time ago, and they would plant the corn, bean, and squash crops close to each other. And we haven't quite fully perfected that here, but we're still experimenting. But their theory was that the corn provided a structure for the beans to climb, and that in its sense with the pea and the pea can climb the barley or the oilseed rape or whichever crop we're going with. The beans give the nitrogen to the soil, which the pea does for us too, and the squash spreads the ground to prevent weeds from growing. In theory, we are working like that with mulches or uh, laying down cover crops over to create that soil armor, and that's reducing the seed and weed bearing. This is just a picture of a pea oat mix, which we would have put um, pollination strip with that too. So there would have been sunflower and Vicelia, you can see buckwheat there. Um, and it's just like a pollination strip to encourage predators and more diversity into the farm. This was the oilseed rape crop that I was telling you about that we put the Austrian winter pea, and you can see that the pea is already starting to die there, but if you look at the root architecture of what that pea has done before it was winter killed, and that will stay in the ground long after the pea has died away, and it has fixed a certain amount of nitrogen. I can't quantify how much nitrogen it has fixed over that time period, but you can see the nodulation here on the roots of the pea, and once they are split open, you can see that there's a pinky flesh in between in those nodules, which is a good sign that it is fixing nitrogen.
Well, so Norm, we have all these curious questions for you, and I'm really unhappy that we're not finished your presentation, but we are
Yeah,
also very eager to answer
yeah,
your
your time. Yeah,
questions. So maybe if it's all right, we can skip to the questions.
yeah, no problem. Yeah,
We don't need a presentation. All right. So two questions from the audience was both one attendee today was remembering that last summer, harvest 22, he was visiting your farm and saw the winter barley with and without the seed dressing inoculant, which
that's
is
right. Yeah.
in correspondence to a second question, which is, do you sometimes do control strips with and without the different dressings you do? So maybe you could elaborate more.
Yeah, of course. We didn't do any, or we didn't take any results from, say, yield or anything from the winter barley crop that you guys would have saw. Um, but you could see the strip where the seed dressing was applied and where it wasn't applied, and the crop stayed greener for longer. And yeah, we're forever, um, we are forever putting in test strips of everything and trialing. Like if we're not trialing stuff every year, we're not knowing what's working and what's not working. So for sure, yeah, we're definitely leaving test strips all over the place.
Yeah, and thank you very much for that. We will be very delighted to hear if you ever harvest some with and without controls.
Mm-hmm.
Another question is, how about the marketability of your intercrop? So when you grow two bicrops together, that could be the OSR and the peas, and how do you manage both the cleaning wise, but also the marketability?
Yeah, so it was in my presentation anyway, but there is a certain amount of market value, but no grain co-ops will give us the price of the two crops. So in we've actually bought a machine from Denmark, a rotary cleaner that has different size screens in it. And I'm currently trying to set that up at the minute, that it will separate the peas and the barley and the oilseed rape and the peas and the oats and the beans and the oats, to separate into two crops and just broaden our market more, and make it more productive, that we get two crops from one field, even though one will be in a less than the other. Like,
And thank you very much. That makes good sense. How
Mhm.
about the windrow compost you do? What different feedstocks do you put into the compost row?
So we have different supplies of horse manure. So we're surrounded by stud farms here in where we live. So we'll have a sawdust manure, which is just a fine sawdust with horse manure and urine in it. We'll have a wood shavings manure with horse manure in it. We will have a wood chip um, cattle manure from outwintering catting pads or in sheds, and a straw-based cattle manure. Um, the balance isn't very well on the carbon to nitrogen ratio there, but the windrow turner helps speed up that process. We have considered putting in slurry or pig slurry maybe to bring up the nitrogen in it a small bit and trying to help the breakdown process.
Okay, yeah, thank you. And a little bit more for the practicality. So you talk both about aerobic bacteria and anaerobic bacteria for your compost theory, I think it was. And how do you kind of determine what to go for, both for the anaerob and the aerob, and then also a practicality of, do you ever get seed clogging in your seed drill when you mix these seed dressings being liquid into some kind of dry products?
So we haven't done a whole pile on the anaerobic compost. I have bought compost covers this year to do trial on that. It'll reduce labor, but you do need to inoculate it before you cover it, like a bokashi kind of style compost. This also keeps a lot of your carbon in situ. It comes out nearly as it went in, but the lignin is broken down a lot more and it's more digestible to soil biology. The aerobic compost is what we're predominantly doing there with the windrow turner. It's all about putting air into the compost and keeping aerobic bacteria and protozoa and nematodes and stuff alive in it. The seed clogging, we don't get any problems with seed clogging. The seed dressing is generally applied the day before or the night before, and left in the bag for the night, so it's fully soaked into the seed by the time it comes around to planting. We have I have messed around with those sort of rates, and I have went a lot higher with the rates, and the seed could be literally dripping or sopping wet. But by the next day, it's fully dry and it flows through the drill as normal seed.
Okay, makes sense. And then some final questions here for my first round of questions. Those are cover crop related. So when do you normally harvest off or get off your spring barley in order to get in your summer cover crops? And also, second question is, it seems that you introduce quite a lot of legumes in both your cover crops and your summer cover crops and your companion crops and your by crops and your crop rotation. So how does that work with any legume related rotational diseases?
So we harvest our spring barley in September, depending on the year that's been had. We don't run a full fungicide program here, so we generally only go for a single-use fungicide in around T2. This means that we don't end up with a green crop coming into. We generally harvest a lot earlier than neighboring farms in September. If it gets any later than the first week of September for cover crops, we will need to cultivate in order to get the cover crop germinated and get some above ground biomass growing. But in general, it hasn't been a problem. The second question, sorry, Frederick, what was that?
Yeah, that was the legume related diseases.
Oh, legume related, yeah. So we don't grow. We do try and rotate it around. The peas aren't grown as a monocrop anywhere. Beans are, and they are one in every 5 years. I think we grow beans. We never move them around. The peas, we don't grow. We only grow maybe 20 acres of peas and oats and peas and barley, or depending on the field size, so it could be 25 acres or 30 acres, and they get rotated around. We'll always try and keep that break as much as possible, but the fact that we can have multi-species cover crops growing in between some of those crops as well is acting as a bridge to disease. And peas aren't they're not a main crop for us, if you know.
Makes sense. And then maybe could you elaborate a little bit more on your both dependency of glyphosate and also maybe a little bit of your thoughts on this big question of maybe a worst case questionable future for glyphosate? Maybe you have a few comments on that.
Yeah, look at I'd be sorry to see it go. I don't particularly like using it, or I don't particularly like it, but it's an important tool and an important stepping stone in what we do as conservation agriculture farmers. Look, even if the regulation was brought in that it was only allowed to be used in conservation agriculture scenarios, so be it. We are trying to future-proof ourselves here. Uh, like it's only ever used for cover crop destruction here. So we have bought a disc harrow, Vaderstad cross cutter disc harrow, which will allow us to disc at very minimal levels, um, and will incorporate some of that cover crop trash into the soil profile, but it won't disturb the ground below too much or compact it. So look, that's our way of kind of future proofing and moving away from glyphosate is to try and terminate the cover crop with a cross cutter disc at shallow, very, very shallow uh levels.
Yeah, very interesting. I think we have time for a few more questions, so I'll just ask the audience for a few more. Nogle spørgsmål her på panel. How's your fertilizer rates and dependency in different crops, both seed-placed fertilizer, but also mainly the nitrogen rates, but also phosphorus and potassium for your crops? What's your approach?
Yeah, so let's see. I had it on a slide here for you. So basically, we don't use any more P or chemical P or K in the autumn anymore. That's completely gone this last 2, maybe 3 years. We're using half the amount of P and K, chemical P and K in the spring. Let me see. So our nitrogen use is down to 120 units on winter wheat and winter barley. It's down to 90 to 100 units on spring crops. We could step that back more. It's just the economic position at the minute that we are on a low input system with fairly decent yields, that it's hard not to push when the price is good, especially in the commodity market. So yeah, look, everything is down, and look, the original plan was always to step back 10% more, 10% more, 10% more, and keep gradually coming down and weaning ourselves off it. But just with the prices at the minute, it's very hard to step away. So look, going forward for the year, I think we'll be still staying at the 120 units and the 100 units. So the we're on 2/3 less fungicide on all crops for the last 2 years. We're up to 50% less herbicide, no slug pellets for the last 2 years, no growth regulator used for the last 2 years, and we haven't used an aphicide since 2018.
Very interesting. Et sidste spørgsmål her på falderebet. Ja, det gør han i forvejen. So how often do you apply your foliar nutrient package? You kind of introduced us for some of the melted urea, and in regards to the melted urea, what do you kind of mean with melted urea? It seems like you did some kind of aeration of your melting process, and then also how often do you apply the foliar nutrient package?
Yeah, so it's just standard prilled urea put into the brewing tank and melted into the water. It's just it's a fantastic opportunity to get carbon sources with the nitrogen. So and it's highly efficient going into the leaf area, targeted leaf area, rather than into the soil and loss of waste and stuff. So we'd go at the normal split rates, we'd go little and often. So maybe it's a bit impractical sometimes to be going out with a sprayer every 10 days during those tillering stages, or you know, uh, we go with those critical times, the same as every other farmer. But just a little bit more often. So at 7 units of nitrogen per hit, we go 3 times, generally split into 1 or 2 times, you know.
Okay, yeah. So thank you very much for a lot of nice answers and